So introduction to Kubernetes. Why Kubernetes? What is a Kubernetes and why Kubernetes? So Kubernetes is something like a container orchestration engine. So what is this? Container orchestration engine. Let me tell you one thing. Usually containers are created either VM or a physical machine or a something like a instance. Right. So for example, this is a EC2 instance. EC2 instance. These are the containers. So these containers are how we can manage these containers. How we can manage these containers. So we can manage these containers through individually, right? So we can deploy, we can pull image, we can build image, we can run image. Everything will be individual, and so there is no there is no orchestration tool. Means there is no tool, there is no one to manage these Docker containers. These Docker containers are individual. Something like if this Docker container down, so who will manage these Docker containers? So individual Docker containers, there is no solution for the managing these containers. So there is a solution called something like a there is solution called as a Docker Swarm. What is this? Docker Swarm. So this Docker Swarm also, this Docker Swarm, cre- this Docker Swarm was created by the Docker, and some extent level it will manage the containers. It will manage the containers. Something like same like as a Puppet and Chef. Initially, the idea was Docker Swarm, but the later Kubernetes. Later, Kubernetes are developed by a Google. So Google developed Kubernetes. Kubernetes is also a orchestration orchestration tool. Something like it will manage the all the parts. Something like you see. So this is the Docker container, for example. This is a Docker container. These all are the pods, walls, Helm charts, everything. Everything will be managed by the Kubernetes. Managed by the Kubernetes. Initially, so it was developed by the Google. So later it will be moved to the something like INF. Okay, so now you understood, right? Kubernetes is a Docker orchestration tool. So something like music orchestrator. So what he is doing? So music orchestrator is doing something like this is a music orchestrator. He is doing which instrument need to play at what time. So he will manage this, right? So orchestrator. So he will manage the entire group of the music group. The same like as a Kubernetes. So manages the all the containers, all the containers. Guys, now you understood what is a Kubernetes, guys? It will manage the containers. So container orchestration. So container orchestration automates the deployment, management, scaling, and networking of containers across the cluster. Across the cluster. So container orchestration automate the deployment, management, scaling, and networking of containers across the cluster. It is focused on managing the life cycle of the containers. So enterprises that need to deploy and manage hundreds and thousands of Linux containers and hosts can benefit from the container orchestration. So before that, it is a Docker swarm. Later, a powerful solution is called as a Kubernetes. Container orchestration is used to automate the following tasks at a scale. Container orchestration is used to automate the following task at a scale. So configuring and scheduling the containers. So configuring and scheduling the containers. But in the uh, but in the normal Docker containers, we are the responsible for doing everything. We are the responsible for doing everything. But in the container orchestration, configuring and scheduling the containers, provisioning and deployment of a containers, a redundancy and availability of a containers, scaling up or removing container to spread application load evenly across the host of infrastructure, movement of a container from one host to another if there is a shortage of the resources in the host or if the host dies. If the host dies, for example. So this is the EC2 instance. EC2 instance is nothing but a host. So if instance is down, crashed, so so if it is an individual containers, so there will be a loss. But if it is in the Kubernetes, it automatically create the another instances, automatically create the container, automatically create the containers. Who will responsible for this Kubernetes orchestration tool? Kubernetes. Kubernetes will manage everything. If if container if container down, so it will create Kubernetes create automatically another container. So host or node down, it will create automatically another nodes. So it will automate the process. The redundancy and availability of a containers also taken care of. The redundancy, scaling up or removing container spread application load eventually across the host of infrastructure, movement of the container from one host to another. There is a shortage of the resources in the host, or if a host dies. Allocation of resources between container, external exposure of the service running in a container with the outside world, load balancing of the service discovery between the containers, health monitoring of the containers and host. Everything will be done by the container orchestrator. Who is the container orchestrator? A Kubernetes is the container orchestrator. Swam. So as I already told you, right? So there is a solution called who will orchestrate the Dockers. There is a solution called a Docker Swarm, but some extent level, so it will not fit for the fit for that. So Kubernetes it will fit for the that orchestration container orchestration tool. Docker Swarm versus Kubernetes. Both Kubernetes and Docker Swarm are the important tools that are used to deploy containers inside the cluster, but there are subtle differences between the both. Features of installation cluster configuration. So Kubernetes installation is complicated, but once set up, the cluster is very strong. Installation is very simple, but the cluster is not very strong. GUI is the Kubernetes dashboard, for example. So Rancher is the tool we can use the GUI. Same like as AWS, I already told you, right? AWS is for Ansible. So Kubernetes is for we have a number of GUI tools, something like a Lens is there, a Rancher is there, or in the Google services, something like a EKS is there, and AKS is there, OK is there. So there will be a number of GUI tools. So GUI dashboard is there is no GUI dashboard, so it is difficult to maintain the containers. Scalability, highly scalable and scalable fast. Highly scalable 5x faster than the Kubernetes. In this point, scalability is a faster 5, 5, 5x faster than the Kubernetes. Auto scaling. Kubernetes can do auto scaling. Docker Swarm cannot do the auto scaling. Cannot do the auto scaling. Rolling updates and rollbacks. Can deploy rolling updates and does automatic rollbacks. Can deploy rolling updates but not automatic rollbacks. Data volumes. Can share storage volumes only with the other containers in the same pod. Can share storage volumes with any other containers. Logging and monitoring. Inbuilt tools for logging and monitoring. Third-party tools like ELK should be used for the logging and monitoring. Kubernetes. Kubernetes also known as K8s. The short form of the Kubernetes is, guys, K8s. Kubernetes also known as a K8s is an open source container management tool. It provides a container runtime, container orchestration, container centric infrastructure orchestration, self healing mechanisms, service discovery, load balancing, and other container scaling and descaling. Initially developed by the Google from managing containerized application in a clustered environment, but later donated to CNCF. Written in which language? Go language. Written is Go language means Google language. It is a platform designed to completely manage the life cycle of the containerized application services using the methods that provide predictability, scalability, and high availability. Kubernetes. So what are the certifications for the Kubernetes? Certified Kubernetes distributions, cloud managed, EKS by AWS, Elastic Kubernetes Services, EKS by Microsoft, Azure Kubernetes Services, GKE by Google, Google Kubernetes Engine. So self-managed, OpenShift by the Red Hat and Docker Enterprise. So local dev and test, micro Kubernetes by Canonical and Minikube. So vanilla Kubernetes, these core Kubernetes project, something like a bare metal, KubeADM, special builds K38 by Rancher, a lightweight K8s distribution for the edge devices. So Kubernetes, a cluster. So what is Kubernetes cluster? What is Kubernetes architecture? Kubernetes architecture, Kubernetes master, will tell you guys. So Kubernetes cluster. So what is a cluster? So cluster is nothing but something like that node will manages the all the a Kubernetes cluster is a set of physical or virtual machines. Set of physical and virtual machines. A Kubernetes cluster is a set of physical or virtual machines and other infrastructure resources that are needed to run your container applications. Your containerized applications is nothing but a Kubernetes cluster. Each machine in the Kubernetes cluster is called as a node. What is that? Each Kubernetes cluster is called as a node. So node is called as a physical or virtual machine. There are two types of nodes in the each Kubernetes cluster. There are two types of nodes in the each Kubernetes cluster. So master nodes and worker nodes. So master nodes and worker nodes. Master nodes host the Kubernetes control plane components and manages the clusters. In the master node, host the Kubernetes control plane components and the manage the clusters. So these are the control plane. So Kubernetes control plane components: API server, scheduler, controller manager, control HCD cluster, control manager, HCD cluster. There are four components: API server, scheduler, controller manager, and HCD. These four are the managing the worker nodes. So worker nodes runs your containerized application. These are the containerized applications. Kubernetes architecture. So Kubernetes architecture. So this is the master node and this is the worker nodes. This is the worker node. Worker node is nothing but a target node. In the master node, there are four components. One is a scheduler, one is a controller, one is a HCD, one is a API server. So one is scheduler, controller, HCD, API server. These are the four components in the master. So these four will be managing the worker nodes. These four will be managing the worker nodes. Worker nodes. So how we can connect these master? We have a web UI also there, web GUI, and you can use the kubectl command. CLI is a kubectl. We have a web UI also. How we can connect with the master node. So worker nodes. So in the worker nodes, kubeproxy, kubelet, Docker, container, pods. What are the pods? Pods are the logical, containers are the physical. So in the Kubernetes architecture, Kubernetes components are something like a means required to run the pods, departments, set these up first, master components and node components. So required for some, but not all the API servers. Yes. Master components are HCD server, API server, control manager, scheduler, KubeCon, KubeDNS, Dash. So these are then the master components. So on the node components, a Docker daemon, kubelet, supervised D, system supervised D or a system D. So to keep kubelet Docker running on kubeproxy, make service IP of how they fit for together. HCD cluster, API server, so HCD cluster stores all the state. It will stores all the states. So API server. So how we can communicate with the worker node through the API server only. API server will manage all the all the all the all the these API server controller scheduler. So API server kubectl, API server control manager, API server scheduler, API server kubeproxy, API server kubelet, API server kubecron, API server dashboard, API server kubeliness. Everything will be managed by the API server. So Kubernetes architecture, Kubernetes master. What is a master? Kubernetes master. Master is responsible for managing the complete cluster. Master is responsible for the managing the complete cluster. You can access master node via CLI, GUI, or API. These master this master watches over the nodes in the cluster and is responsible for the actual orchestration of the container on the worker nodes. On the worker nodes. For archiving fault torrents, there can be a more than one master node in the cluster. So it is the access point from which administrator and the other users interact with the cluster to manage the scheduling and deployment of the containers. So it has four components: HCD cluster, scheduler, HCD, scheduler, controller, and API server. So Kubernetes master, what is a HCD cluster? What is a HCD cluster? HCD is the distributed reliable key value store used by the Kubernetes to store all the user to store all data used to manage the clusters. All data used to manage the cluster. So it will store the key value stores. So when you have a multiple nodes and multiple masters in your cluster, HCD stores all the information on all the nodes in the cluster in a distributed manner. HCC is responsible for implementing locks within the cluster to ensure there are no conflicts between the masters. So what is the a scheduler? Scheduler is responsible for distributing work or container across the multiple nodes. It looks for a newly created container against them to a nodes. Kubernetes API server. What is the API server? API server manager. Master communicate with the rest of all the cluster through the Kube API server. The main access point is the controller panel. The main access point is the control point. It validates and executes the user REST commands. A Kube API server also makes sure that the configurations in HCD match with the configuration of a container deployed in the cluster. So control manager. The control are the brain of the behind orchestration. They are responsible for noticing and responding when the nodes, containers, endpoints are closed out. So controller will verify the worker nodes. So if there is any kube control manage the Queue control is the brain of the orchestration. It are the responsible for noticing and responding when the nodes, containers, and endpoints goes down. The controller make decision to bring up the new containers in such cases. Cube controller manager runs control loops that manages the state of the cluster by checking the required deployments, replicas, nodes are running in the cluster. So this is at the master node. Kubernetes master node. So yeah, so we have a kubectl also there, right? So kubectl is the command line utility using when we interact with the KTS cluster. How we can interact with this cluster? So you can interact with the cluster something like kubectl. Kubectl get pods, kubectl get nodes. kubectl describe nodes, kubectl will describe pods. So it will be managing the command line. kubectl is the command line utility using when we can interact with the client cluster. So uses API provided by the API server to interact, also known as the kube command line tool or kubectl tool or kube control command. Use it to deploy and manage the applications on the Kubernetes. kubectl run nginx used to deploy an application on the cluster. kubectl run nginx used to deploy an application on the cluster. kubectl cluster info. So kubectl run nginx. This is the command. So nginx is the container. So use it to deploy an application on the cluster. So kubectl run is to something like docker run, the same like as a docker run. Here kubectl run. So it is to deploy an application on the cluster. kubectl cluster info used to view the information about the cluster, and the kubectl get nodes used to list all the nodes part of the cluster. So Docker, so same like as a Docker. So this is the kubectl is the command for the CLI. So the containers, there is no GUI solution. So Kubernetes provides the GUI solution for the containers. So worker nodes. So kubelet. So this is the kubectl. This is the kubelet, kubeproxy, and Docker containers. So kubelet worker nodes have a kubelet agent that is responsible for interacting with the master to provide health information of the worker node. This kubelet is same thing, something like a. So this is the chef server, for example. So how we can communicate with the chef server and chef target servers. So there will be agent need to install on the chef agent will be installed on these servers. So how we can verify it, something like this is like a kubelet. Kubelet will will check the kubelet will check the containers. Kubelet will check the containers. So kubelet worker nodes have a kubelet agent that is responsible for interacting with the master, provide the health information of the worker node. So kubelet is the agent for the a master node. Something like if it is a chef server, so these are the chef clients. So chef clients need to run the agent to communicate with the master server. Same like as a worker node have the kubelet agent that is responsible for the interacting with the master to provide health information of the worker node. So to carry out the actions requested by the master on the worker nodes. kubeproxy is the responsible for ensuring network traffic is routed properly in the internal and external service as a required, and is based on the rules defined by network policies in kube controller, manager, and other customer and custom controls. What is K3s? K3s is a fully compliant Kubernetes distribution with the following enhancements: packaged as a single binary, 1000 MB memory footprint, supports ARM and x86 architectures, low weight storage backend based on the Scalate 3 as a default storage mechanism to replace highware STD server. Docker is replaced by a favor of the containerd runtime, inbuilt ingress controllers. So these are the K3s. Yeah. So Kubernetes, what are those? Kubernetes parts. What is a part? Kubernetes parts. Kubernetes parts. Basic scheduling unit in Kubernetes pods are often imperial. Kubernetes does not run containers directly. Kubernetes does not run the containers directly. Instead of wraps one or more containers into a higher level structure called as a pod. A pod contains the something like a pod contains the containers. So basic scheduling unit in the Kubernetes does not run containers directly, does not run the containers directly. So it will run the instead of a wraps one or more containers into a high level structure called as a pod. It is also the smallest deployable unit that can be created, scheduled, and managed a Kubernetes cluster. Each pod is assigned a unique IP address within the cluster. Each pod is containing a unique IP address in the cluster. So there are the containers. Pod having the containers. So pods can hold multiple containers as well as, but you should limit yourself when possible. So because pods are scaled up, scaled down as a unit, all containers in the pod must scale together, regardless of their individual needs. This leads to a wasted resources. So this is the Kubernetes container. In the Kubernetes container, node will be there. In the nodes, there are the pods. In the pods, there will be a containers. Pods, there will be a container. Pods. Any containers in the same pod will share the same storage volumes and network resources and communicate using localhost. So K8 uses AML, right, Ansible to describe the desired state of the container in pod. This is also called as a pod spec. The objects are passed to the kubelet through the API server. Pods are used as a unit of the replication in the Kubernetes. If your application becomes too popular and a single pod instance cannot carry the load, Kubernetes can configure to deploy a new replicas of your pod to the cluster if necessary. So this is the pod. So how we can communicate through the local host. So pod having the IP addresses. Pod having the IP address. So something like it is a 10.1.0.1. So it will communicating through the local host inside the cluster. So using the example of the above figure, you could run the curl 10.1.0.0 to communicate the one container and call 5000 to communicate to the other containers from the other pods. However, if you want to talk between the containers, for example, calling to top container from the bottom one, you should use the HTTP localhost. So scaling pods. So all containers with the pod get scaled together. You cannot scale individual containers with this pods. A pod is the unit of the scale in Kubernetes 8. So recommended way to use have only one container per pod. What is that? Only one container per pod. Multi-container pods are very rare, very rare. In the K8s, init container is sometimes used as a second container inside the pod. So this is the container pod. It scales automatically. Init container are exactly like as a regular container, except that they are always run to completion. Each init container must complete successfully before the next one starts. If your pod init container fails, Kubernetes repeatedly restart the pod until the init container succeeds. Imperative and declarative commands. Kubernetes API define a lot of objects resources such as namespace, pods, deployment services, secrets, config maps, etc. There are two basic ways to deploy objects in the Kubernetes. One is imperative way and the other one is declarative way. So imperative way involve using a verb-based communication like kubectl run, kubectl create, kubectl expose, kubectl delete, kubectl scale, kubectl edit. These are the imperative, suitable for testing and interactive experimentation. Declarative objects are written in the YAML files and deployed using the kubectl create or kubectl apply. Best suited for production environment. So what is the declarative environment? So the imperative environment is best suitable for the dev environment, non-production environment. So Kubernetes manifest and spec file. So K8 is object configuration file written in YAML or JSON. They describe the desired state of your application in terms of Kubernetes API object. A file can include one or more API objects distributions. So manifest file, API version, kind, metadata, spec. These are the four items in the file. So version of the Kubernetes API used to create the object. Kind is of the object being created. Metadata that data that helps uniquely identify the object, including a name and optional namespace. A spec configuration that defines the desired of the object. These are all the something like API version v1, kind, pod, metadata, name, spec, containers, names, containers can provide the same. So manifest files can manage pages. There's a list of all KTS API supported objects on the versions. kubectl API resources, kubectl API versions. kubectl explain object option. kubectl explain pod. kubectl explain pod dot API version. kubectl explain pod dot spec. These are the command line tools. Kubernetes, once the cluster is set up, kubectl version. So nodes are the missions on your cluster. There are available resources that can come and do. So this is the Clay 8 cluster. So this is the data center one. This is the data center 2. The data center node 1, node 2, node 3. Data center 2, there are 6 nodes. Nodes are the missions in the clusters. kubectl version. So kubectl version -oml, it will get the version of the kubectl. kubectl get nodes -node. So so if kubectl get nodes, it will get the nodes. So once the cluster is set up, kubectl cluster info, it will show the cluster info. Creating a pods. How you can create the pods? kubectl run pod name, image name. So kubectl run nginx -image nginx dry run client. So it will run the kubectl run image directly. So through the YAML file, it's creating a pods imperative way. So we can use the imperative ways, creating pods. So this will show you on the guys real time. So pod networking, how will we get the pod networking? Replication controllers. So something like a behind the screen. So what it will be do? So labels and sketch cards. We'll show you guys. We'll show you. So when we start the Kubernetes. So deployments is easily rolling back, rolled out. We'll show you guys. We'll show you. This is the Kubernetes introduction. Guys understood? So who will manage the containers? So there is a solution called Kubernetes. So Kubernetes orchestrate the containers. Guys understood? Guys, Joshna, Kim, Vamshi, understood?